welcome to our workshop series Kubernetes from Zero to Hero. Over the next 6 weeks, I will walk you through the basics of microservices and Docker, Kubernetes basics, Kubernetes security, the concepts of operators, and Istio mesh networking. See you every Wednesday afternoon, 2 p.m. Central European Time. Enjoy. So let's talk about labs preparation. We had our prep session yesterday evening. We only had 2 people dialing in, and only one of those spoke actually to us. So apparently there haven't been problems. So just to explain it rapidly for the newcomers, in the prerequisites you had to download a VM. So either for VMware or for VirtualBox, or I put an OVA as well that you can run on KVM and whatnot for the really technically good people. When you start that up, it will run a Kubernetes environment. It has the tools that we will be using today and that we've used in the past sessions. So it's pre-initialized, and it will start also directly in the VM, what I call the personal training environment, which basically is a web interface that gives you the different labs that you will have to execute. So this VM has no expiration date, so you can do those labs today, or you can do them in July, or you can do them in September. That's absolutely no problem. Okay, so no expiration. That's why I packaged it up like that. Like that, you have your own complete VM with everything in it to do all the different labs that we're doing in those 6 installments. So I think you have done that already. When you access it, when you get this software update, please dismiss that, because otherwise it might want to reboot, which is not what you want. But just say, remind me later, we don't need that. Again, as I say that every week, I designed that specifically for Switzerland, so there's no other keyboards in there, so you have to click on the upper right-hand side to add your keyboard layout so that you can type with some comfort. Then most of you hopefully have already done that. You start the terminal, and then you just type /welcome.sh. This will start Docker, that we won't be needing today. We'll start Minikube, which is the Kubernetes environment, prepares the networking plugins, starts your personal training environment, and the Kubernetes dashboard. At some time you have to enter your name. Please put in something that you can identify you with. I have a centralized dashboard where I see how you advanced in your labs, that I'm having a look at from time to time to see if some people are stuck. But that's only for that. We don't register, we don't report that, and after the session it's being deleted. So for troubleshooting, if it really doesn't work, you can try to do a .reset environment.sh. So that scratches everything, the Minikube VM, everything that's on the machine, and restarts basically the whole environment. But that can take up to 30 minutes, depends a little bit on your internet connection, because it has to re-download all Docker images. Another possibility would be just to shut down your VM, get back to the snapshot. There's just one snapshot per VM, and then restart it and just start ./welcome.sh again. That will be faster than that. If you close your personal training environment webpage, just run Minikube service student UI, then you get back up. And we had in the beginning some problems, some challenges on Windows 10 with the Hyper-V that was running. So VMware doesn't play nice, and I think VirtualBox neither, when Hyper-V is running, because we're using what we call nested virtualization. So you have to turn that off for the time of the lab, and then you can turn it back on with hypervisor launch type auto. So that's basically it. Then we had some questions about can I do the labs on my own machine? I already have Docker and stuff installed. You can do that. You can clone the training directory. I created the preparation script .welcome.sh, which will basically start everything you need. But you have to have Minikube installed, you have to have Docker installed, and you have to have Git installed. That's the absolute least that you need. And you won't have any of the security tools pre-installed on your machine, obviously. But in the lab session, there's a link to every tool, so you have to get to the website and install the tools yourself. But it should work. It's absolutely untested. Obviously, I cannot test all the different combinations that we might have. So no guarantee here, but you can try to do it if you're technically good enough. Having said that, if you want to troubleshoot, there's a tool installed in the VM that's called K9s, K9s, which is basically the Norton commander for Kubernetes. It's the first tool that I'm installing each time I get a new machine or a new VM. It helps you look at your Kubernetes resources, the pods, the services, the deployments, whatever, to edit them, to delete them, to see the logs, and so on and so forth. And if you want to check that everything's okay, just run K9s and then check that there's no red lines. So you shouldn't have any error or crash loop back off, and no container creating. So you should have running everywhere and 1/1 for the red state. So give it some time when you start the welcome.sh. It takes some time to get initialized and to get stable. So don't freak out too early. If after like 20-30 minutes it's still not running, try to reset the environment. Good. And when it's completed, you should have the Firefox opening up automatically, and you should get the Kubernetes dashboard and what we call the collector, which is the personal training environment, popping up automatically. And when you see that, you know that you're ready to go. Good. And afterwards, when we start the lab, you will have a first tab called Courses with a drop-down. So here we'll be selecting JTC 17 Kubernetes Advanced. And you click on Begin Course, which takes you to the second tab, Classwork. And here you have another drop-down with all the different steps of the lab. So recommendation is to go through one by one. Don't jump around. And when you've done the content that's down here, click on Complete and press Mark to complete it, and you go automatically to the next step. If, however, you have to go back to a step or something, you can do that through the drop-down. On the Statistics tab, you can see where you stand with finishing with progress on the lab. So you will see the number of steps that you have and check boxes for all the steps that you have completed. I have a centralized dashboard that I'm looking at from time to time, where I can see the different people on the left here, and that's where your name will pop up, and I can see where you stand in the lab that we're doing. Good. Questions? I cannot see any questions on Slack, so I guess we will start. Okay. So, introduction very rapidly, just what happened so far. So in the first installment, we have seen that everybody loves containers. We have been talking about containers, Docker, microservice transformation, and so on and so forth. In the second part, we've been talking about Kubernetes, basics of Kubernetes. What are the elements of master nodes, of worker nodes, how it's communicating, how you deploy an application, and so on and so forth. Last week, we have seen the introduction to Kubernetes security with the different attack vectors, different attack surfaces. So the first one was through the applications, obviously through the applications that you have in your Kubernetes cluster that are exposed to the internets. So if you have some security vulnerabilities in your applications that are being exposed, you have exactly the same challenges that you have with classical and normal applications. So you have to secure your workloads, obviously. And there are some other things that you have to respect here. Then the volumes, where your persistent volumes are being stored. So we didn't go in there and won't for this installment. We don't have time enough for that, but that's something you have to secure. Then we have the management vector through the API, on the API server to the kubelet, or directly to the Docker engine if it's not secured, running on the worker nodes. And last but not least, etcd. If you get access to this distributed storage, which is based on etcd, which basically is the brain that contains the actual state of your cluster and the desired state of your cluster. So that's where we say, okay, we want our cluster to contain this and that pod and running like this and like that. So that's where you define how your stuff has to look like. And then it takes the information out, it goes out and deploys that to the worker nodes and puts back the actual state into the etcd. So if you get access to that, basically you can do whatever you like. It's even worse than if you get access to the management API, because here you have some control over what comes in and what the format is and whatever. So it's vetted, it's controlled before it's being stored into the etcd. And if you have access to the etcd, you can basically write in there whatever you like. So so it's even worse than having full access to the API. Okay. So then we've been talking about how to reduce the attack surface. So the first one obviously is etcd. We'll be talking on one slide about that today. Controlling access to the Kubernetes API, that's the big topic of today through role-based access control. Controlling access to the kubelet, enforce resource limit, usage limits for workloads. We have been talking about that a little bit last week and the week before, so that you cannot starve a cluster to death, so that you cannot do a denial of service attack just by eating up all the resources of your cluster. Infrastructure credentials, we've talked about that. Logging, we've talked about that. Linux security features for the containers themselves, we talked about last week. The privileges as well, network policies as well. Scanning of your containers, we'll talk today about that. And Kubernetes secrets you talked about last week. So if you missed last week, you can always go back to the recording. And again, you have your VM with the lab, so you can do the lab from last week or the weeks before, and watching, if you like, the recordings of the trainings that we've done. Having said that, questions. Okay, instructions to download VM for workshop. Okay, that's already been answered by Yuri. Thank you. So, if there's no questions, let's go into some more security elements. So the first one is securing the API, and that's probably one of the most, well, it's not straightforward, but of the first things that you want to do is to make sure that your API is being secured correctly. So there are three things here about that, and I've been talking very rapidly about that last week. The first one is authentication. So that's basically the who am I? So here we can use tokens or certificates or OpenID connect providers or IDC and so on and so forth. So for example, I can be a developer, so I could create, view, and so on and so forth. The tester can create, delete, update, for example, and an admin has all permissions. So that's checking who am I. And then we have the authorization, which is the can I do something. So is the user that has been authenticated authorized to do, for example, to delete a deployment or to create a namespace or something like that, okay? And then we have the admission control. Those are the famous webhooks. I'm talking about that in a second, which can do some very interesting things to your deployments and to your communication with the API server. Okay, so authentication, I won't go into detail with that. Very often we have integration with LDAP or Active Directory or something through this OpenID Connect. So normally we use JSON Web Tokens, so JWTs, to authenticate. And there's an open source project called DEX, which acts as the portal between an LDAP server and your Kubernetes cluster. So I won't go into detail. That would be a topic for a whole session, I guess. And that's not one of my my preferred topics. I don't know all the ins and outs about that, but know that there's ways to integrate with LDAP. Afterwards, if you use solutions like OpenShift, for example, from Red Hat, they have that already integrated, so you can, out of the box, you can integrate with an LDAP or an Active Directory directly from within OpenShift, so you don't have to do that yourself. Because it can be a bit tricky, this whole DEX thing. Good. Now, admission webhooks. So the admission part. As I said last week, there are two different types of webhooks. The first is mutating, and the second one is validating. So as you can see, we come in, your API request, when you do a kube control, create -f and then a YAML file, for example, to create a deployment. This will be sent to the API server. So kube control sends that to the API server in the back. Then you have the authentication authorization. We've seen that already. And then we have this mutating admission webhook. So this is something where you can modify the YAML code that has been sent to the API server automatically, given some rules or something that you have implemented. The best example, and I've been talking about that last week, and we will talk about that in the 6th installment for Istio. Best example, for example, is this sidecar injection. So every pod that you deploy in Istio has an Envoy proxy sidecar deployed within. So you have the pod with your application container running, and we have a second, what we call sidecar or ambassador container with the proxy running in the same pod, which handles all the communication afterwards in the service mesh. So to not have to do that manually, you can use this mutating admission webhook. So imagine you create your deployment, your pod. It goes to the Istio webhook. It will add YAML code for this sidecar into the complete YAML that you've sent, and then it goes on to it in the whole chain. So afterwards we have object schema validation, so that's pretty basic, and then we're coming to the validation admission webhook, and this one checks. It's the last guard, if you like, before the thing is persisted and or written to etcd. So this validating webhook takes the YAML code and can do some stuff on there. For example, image scanning. We talked about that last week, and we will be talking about image scanning in this installment. So you could, for example, say, okay, I get a YAML in there where I want to create a pod with a container in it, and then scan this container automatically. And if there's some vulnerabilities in the container, just block here and don't persist it to etcd, and you get an error back to kube control. Now, as I said, having an image scanner here obviously would slow down operations, because each time you want to create something within Kubernetes, it will have to scan the image. So what we will be using more often is things like Notary or something, where you can just say, you can notarize, if you like, images, or you could use other solutions that just list, for example, the hashes of the images that are allowed to be deployed, stuff like that. So like that, you can just check the hash of the image and say, okay, it can go through or cannot go through. So here we can really have a lot of control about what can be persisted definitely to my Kubernetes cluster. So those are the webhooks. Are there any questions? Let me have a look. Okay, question: can we use HashiCorp's Vault for authentication? Very good question. I haven't been working a lot with Vault, but as far as I understood, Vault is more a secret and what do you call that? Well, secret management solution. So where you can manage your everything that should be secret, your passwords and so on and so forth. I'm not sure if they support authentication. Might be, but I wouldn't know, frankly. I'd have to check. Something else that you can use for authentication and authorization, and we will see that in 2 weeks, is Istio. Istio has built-in authentication, but not for the API, for the Kubernetes API, but for the running applications that you want to expose to the external world. So here, authentication authorization is really on the API level for Kubernetes, and then we can have authentication authorization for the workloads, so for the running pods and containers and whatnot, through Istio. So for the application workloads. Okay. Ramesh is typing. I'm perhaps waiting 2 seconds to see if Ramesh has a question to this topic. Otherwise, I go on. So he stopped typing. Okay. So I go on. Otherwise, I take the question afterwards. Now let's go through authorization, and that's where we'll be talking a little bit more. Authorization is done through Rpac, role-based access control. Sounds simple, but is, I find, really complicated. I guess I'm not the most stupid person on earth, but it took me probably 1.5 years to more or less understand how it works and what you can do with that. So what do we have in Rpac? So we have different building blocks. So first we have objects. So those are Kubernetes objects, can be pods, persistent volumes, config maps, secrets, nodes, deployments, namespaces, you name it. Every Kubernetes object that we can have, as well as those famous custom resource definitions where I can define my own Kubernetes objects that will be living in the cluster. We will see that next week with the operators a little bit more into detail how to create one of those custom resource definitions, or CRDs as we call them as well. Okay, so those are the objects. That's pretty straightforward. Then we have the verbs. So what can I do with those? I can create, get, delete, list, update, and so on and so forth. Pretty simple as well. And now we have to tie that together. So how do we do that? First, we have what we call rules. So here we can say what verbs, so what actions can be carried out on a group of resources. Okay, so for example, delete pods or delete deployments, for example. Okay, then we have the roles or cluster roles. I come to that in a second. So those consist of rules to say, okay, what's the rule that this role can have? So this role can list all pods, it can create namespaces, but cannot delete namespaces, and so on and so forth. Now, the difference between roles and cluster roles is that roles are applicable just to a single namespace. So you say this role is valid just, for example, for the default namespace, for the kube system namespace, and so on and so forth. Cluster role is cluster-wide, so it's visible across the whole cluster. So you create a cluster role. For example, kubeadmin, cluster admin, sorry, is a default cluster role, and the most dangerous one. I'll be talking about that. Then we have the subjects. So that's new, that we have that to the right here. So that can be user accounts, service accounts, or groups. Now, there's no notion, there's no Kubernetes object called user. So there's no notion of users themselves. So a user is how do you say that? Is identifying himself through tokens. So when you call the kube control, you have your Kubernetes context, your kube context. We talked about that 2 weeks ago, and there your user will be defined with the tokens to get access to the API server. So there's nothing such as a user account within Kubernetes, which makes stuff much more complicated, by the way. Then we have service accounts. So those are namespaced accounts to provide certain services. So very often we work with service accounts to give some permissions to other parts and what can be done within the namespace. And then we have groups, and they reference multiple accounts. So we can have groups like cluster admin and so on and so forth. And then at the end, we have role bindings or cluster role bindings. So role bindings bind subjects to roles. So again, you remember that again, it's for the third time, the holy trinity of Kubernetes. We had the holy trinity with developments that create I got a blank here. So deployments that create replica sets, and replica sets create pods. 3. Then we have a pod that asks for a persistent volume claim, and the persistent volume claim creates a persistent volume. And here we have the object or the subject that is bound by a role binding to a role. Okay, so you have the schema here to the right. So you can say, for example, a service account is bound through this role binding to a role that can get and list pods, for example. Okay, and all of that is happening through the command line, through YAML definitions, for example, and it is obviously, it can be extremely complicated to get an overview over how this works, what roles you have, and so on and so forth. There is a Kubernetes kube control command. I think you can. I don't remember what it is. I haven't put it in the slides. It's kube control can I, and then you say, for example, list on this and this object, and it will tell you yes you can or no you can. So you can check that for each object, for each operation that you want to do. But there's no such way as a graphical interface or something to get an overview. Obviously, again, solutions like OpenShift, Red Hat's OpenShift have stuff built in to handle that more efficiently. You can import the users from an LDAP, bind them to groups or to roles, and so on and so forth. Makes it a little bit more easier. Now, an example here. So I have my user. I have here, for example, and I have my role. So the role would say, I have a role with a name. So the kind is a Kubernetes object role. It's named pod reader, for example. And then I say API groups. So API groups is empty. So it's all API groups. I could start to filter on that. The API groups are what you have on the very top of your YAML when you're creating a deployment, for example. And what is it? apps/v1, for example, stuff like that. So if you leave it empty, you don't filter on that. Then you say resources, so all pods, and I can get and list them. So I won't be able to delete them, to modify them, to create or whatever. Okay? So that's the role. And then I do a role binding called pod reader, whatever. I say, okay, the subject is a kind user called John, and the reference to the role is to pod reader. So that's the red one. So referencing back to the role. So like that. Now, if I have, or if I identify against kube control with a JWT token and user John, it will pick up this role binding and will know that John can only get and list pods and can do nothing else in this cluster. Okay? So no questions in Slack until now. Very good. Now, why is that complex? Well, the first one, and that's the most fun one, is there's a built-in role called cluster admin, basically God in Kubernetes terms. Gives you unlimited access to the cluster. So this you should only grant if a user really, and then think a bit, and really needs it, because you can do everything with that. So please, if you can, define specific roles for a person. You can give them a lot of permissions, but try to not use cluster admin. Now I'm saying that, and I'm using it all the time, because when I'm doing demoing with customers or prototypes or stuff like that, if you want to deploy something, let's say a logging solution or something, and you get back that you're not allowed to do that, what you do, obviously, you add cluster admin rights, because you cannot be bothered. You have to go fast. But that's exactly the danger. So if you do that on a dev cluster, development cluster, that's not a problem. If you do it to play around, that's not a problem. But don't do that in pre-prod or prod clusters. Never, ever. Okay? You should have 1, 2, maximum 3 cluster admins, because they really need that, and they should be operations people, and they should know what they're doing. Okay? Okay, that's the first one. So cluster admin, be very careful with that, whom you grant that to. Then a challenge that you might have is duplicated role grant. So imagine you have a service account, for example, and you have 2 role definitions that are linked to it. So I have 2 roles, 2 role bindings to the same service account. The thing is that those roles might overlap. So I might have one role that has been created in the beginning, saying this service account can list and get all the different objects in my cluster. So just read. So read out the status and see what's there, but cannot modify it. Then there might be a second one that has get, list, and create, for example. So now you have twice get and list and once create. So it can get quite tricky afterwards. If you want to revoke access, for example, if you don't want this user to have creation or deletion or whatever, right? It can be pretty tricky if you have several role grants for one subject, that we call that. So user or service account, whatever. So try to make sure that you just have one role with one role binding per user, per service account, to make sure that everything's in there and that you have that defined once and for all in one role, or with one role binding. Because you can create one role which would be I don't know, admin on namespace default, for example, which can do everything on the default namespace, and you can grant that to different service accounts, to different users. So one role can be bound with different role bindings to different subjects. That's not a problem. Okay. Then unused roles. So when you want to delete an access definition, a role or anything, you have to delete the role and the role binding. So what could happen is that you delete the role binding, like that you doesn't have the access anymore, okay, which is good, but the thing is that there might be roles that are not used, that are not referenced anymore, and that might increase the complexity of your Rpac management. And the worst ones might be if you want to delete the role and role binding, and you only delete the role, and you keep the role bindings around. So if there's binding, it points to nothing, to empty, because the role is missing. But if by chance anyone creates a new role that has the same name than the one that you deleted back then, this role binding might become unexpectedly active again. So I don't know, if you have a role binding that's somewhere around with default, for just let's say default, just stupid name that doesn't mean anything. And if someone goes in and creates a role binding, the role that's called default, that has super admin, cluster admin rights, this user that you had suddenly is a cluster admin. So be very careful with those. It's pretty tricky, as I said, to handle that correctly. So keep in mind, always think about this least privileged access. It's this Occam's razor principle. So give the least privileged access. Prefer to get a phone call from an angry developer saying, yes, I cannot create my deployment in namespace XYZ. Can you please add me? Than to see that some rogue actor had too much access and deleted your production pods, for example. So that's very important, but it's easier said than done. Now, what can help here? So I already said you can do this kube control, can I something, and it will tell you, yes, you can, no, you can. But there's some tooling, and we will be seeing some of those in the labs afterwards. So the first one is Rpac Lookup. So I can do an Rpac Lookup for example, OpenShift, which is the user here, and it will give you the different subjects, the scope, and the role that they have. So it will look for OpenShift, and it will tell you, okay, my service account OpenShift, for example, has a cluster role image puller, for example. Okay, if you do an Rpac Lookup for root, it's in this case here, we'll say subject is root. The scope is cluster wide, so it's for the whole cluster, so it's a cluster role binding, and this root has the cluster role cluster admin. So that's my absolute god, my can do everything in my cluster. If you look here, the service account OpenShift here is scoped to the namespace OpenShift and has the cluster role image puller. So that's a role that has been defined cluster wide, but bound by a binding to the OpenShift service account. So you can do. Let me just go back to here. So you can have a cluster role that you define once for the whole cluster, and you can just do a role binding. You don't have to do a cluster role binding on a cluster role. So you can have a global cluster role and just bind them through a normal role binding to a specific service account, for example. That's pretty important. So Rpac Lookup is the first tool that can help you understand a little bit what the different roles are that has been given. Then there's a very cool tool, command line tool called Rpac or Rpac. So here you can say, for example, Rpac minus namespace default, and it will show you all the different elements that you have, endpoints, deployments, daemon sets, and so on and so forth, and see what you, with your logged in user, can do with that. So, for example, here, with this one, I can list almost everything except these events and leases. I can create everything except controller revisions. What is it? Those are here. Events and limit ranges, for example. Okay, and then for update and delete is the same. So that's already a little bit more graphical. So it helps you a lot to see okay, what can I do within my cluster? Okay. So you can see it here, some examples. So Rpac namespace default, so that gives you what we've seen here. But you could also say Rpac verbs get delete watch or something, and then you will see the detail for this operation. We will be using that in the labs afterwards. And then where a pretty cool one is Rpac view. So that's something you have the link down here, and you have it also in the lab instructions. That's a tool that starts a HTTP server, and then you can start exploring, and you will be doing some exercises on this one in the lab to see who can do what. So you have the cluster roles and the roles. You can see, for example, I don't know what. Let's get something here for this one here. For namespace public, you could have a look at the subject. So who this is. And then you can see, for example, config maps I can update, events I can create, update, P, I don't know what P would be. I'd have to check, patch, sorry, and so on and so forth. We have it up here, create, delete, get, and so on and so forth. So it's a graphical matrix that shows you, and you can have, there's a search function, so you can, for example, check out who the users are that have cluster admin rights, which is pretty practical. So you can search for that, and I think that you can be doing that you will be doing that in the labs to check out who has the cluster admin rights assigned to them through role binding. So pretty interesting. Then there's another one called Rpac. Again, it's command line, if I'm not mistaken, and it renders. You can either render it in HTML or in JSON, and it gives you a graphical overview for every namespace with the different service accounts in the namespaces, and gives you the different access that you have. Now, it looks simple like that. I'm not sure if we'll be doing that in the labs, but usually it's not small like that. Usually it's something that's, well, where's the camera? Here, large like that and high like that. So it's just like that, and then you have to zoom in and look for your stuff. But if you want the default topology and understand graphically how those hang together, you can do that. Okay, so can be cool, but perhaps if it's big clusters with a lot of namespaces, it can get a little bit crowded in there. Good. So let me pause here and take the questions. Okay, that's a cool, useful tool. Thanks. Well, no problem, Zimi. That's why I'm here. In case you have some Spring app, so yeah, where some security defined that it not cause conflict with your suggestion. What is the best way to do that application side or Kubernetes side? Okay, I'm not 100% sure I understand, but okay, you have a Spring application, containerized, I suppose, sorry, and you deploy that in your Kubernetes cluster. So does it not conflict with your suggestion? So to be very clear, and perhaps to wrap it back once again, you have your application that has been deployed in your cluster, okay? Now there's two types of securing this application. there's authentication and authorization for the application itself. So when you open the web page into your application, do you have to authenticate? Do you have to log in? And so on and so forth. Has the application itself some user management and anything? But that has to be built in the application, in the Spring application. Or, as I said, we will see in 2 weeks, you can use Istio, the Istio mechanisms for that. What we're talking here about is access to the Kubernetes API. Okay, but this Rpac doesn't somehow restrict or control access to your workload itself. It restricts what you can do through the Kube API to your running workload. So can you delete the Spring app, for example? Or can you update it? Or can you modify it? Can you patch it? Whatever, okay? So Rpac will say, I will be doing a kube control delete Spring app, for example. And Rpac will say, will know, okay, this guy is on the service account, or is this and that user has this token. Can this guy delete this application? And if I don't have a role binding that has a role that has the authorization to delete a pod or a deployment or whatever, in that case, it will tell me, no, you cannot modify this application. Okay? So this is two different types. We have authentication authorization for the workloads themselves, which is handled within the application, within the Java or the .NET or whatever application itself, or through Istio. And then we have the authentication authorization to the API. So what can you do with these workloads? Can you create it? Can you delete it? And so on and so forth. I hope it's clear. We'll see. Okay, I go on a little bit. He's typing, so I take it. I take it whenever it pops up. Okay, so just some tips and tricks again. Disable anonymous access. By default, requests to the Kubernetes API and the kubelet, both of them, to the HTTPS and not rejected and are treated with a given username of system anonymous, okay, which has a group system unauthenticated. So the request comes in, but the user that's attached to that is system anonymous, okay. So that's where you might, well, you have an attack vector which doesn't have to be, because you can just pass a flag to the kubelet and to the API server, which is an anonymous auth false. Like that, they won't go through. They will directly be blocked at the ingress level. Okay, so do that. Normally for solutions again as OpenShift and stuff like that, that's already done. You don't have to do that. But if you try to build your enterprise cluster yourself, make sure that anonymous auth is set to false. Okay. Like that, you mitigate the risk, and you're sure that you cannot have like denial of service attacks and stuff like that. Because if it accepts them and it flags them with the user system anonymous and pushes them further, it goes through several stages before Rpac will say no, system anonymous cannot do anything. Please go away. So if you do a lot of those calls, you might flog your system, the API server. Okay, that's the first one. So more specifically to securing the kubelet. So anonymous, we've seen that. You can set an authorization mode. So set it to anything, but not always allow. Okay, because if you set authorization mode always allow, it will be wide open. And then read-only port 0, that's just a little thing. I won't go into detail, but that's best practices. So try to set up to 0. Then we have etcd. So etcd traffic should be encrypted to use as HTTPS. Okay, so you have to specify a certificate file and a key file. It's not very complicated, but make sure that your etcd is using HTTPS and not HTTP, so that you cannot get in. And client cert auth equals true, like that it checks the client certificates, okay? Like that, you're sure that the person is authenticated correctly and cannot gain access to etcd easily. It's very technical. It's just some bullet points that you can take care of. So let me just go back. Okay, it says yes, but you can bind them, write, or block them. As I tried to bring it to run your standalone version, they had huge trouble with anonymous. It says anonymous access is refused, so you were that. I'm sorry, I'm not sure I understand. When you say yes, but you can bind them, write, or block them. You can only bind and block. Rpac is really just for the API, so it's not for access to the thing. So if you're talking to run your standalone version, okay. So the version that you are running on your computer with Minikube, I guess. So I had huge trouble with anonymous. Yes, I mean Minikube now I think doesn't accept anonymous. So normally you have to get the cube context, which should be more or less automatic when you start Minikube. But otherwise, just Google Minikube set context or get context. I think it's Minikube something. It's Minikube with an option that gives you back the context in case. So I'm not sure if that answers the questions. Otherwise, please correct me and add to that. Okay. Another thing, but that has been pretty much mitigated. The API server can serve requests on 2 ports. Well, for the standard one is the secure port. That's the one that we want. And up until Kubernetes 1.10, well, which is a little bit older by now, there was a localhost port open, 8080, without any authentication and any authorization. So there's this insecure port flag 0 and insecure bind address. So make sure that they're set like that. So insecure port flag 0 and insecure bind address, that you don't have that. It has been deprecated, and I'm not sure if it has been removed already, but just make sure. But in that case, if anyone has access to the host machine where your master nodes are running, he can just connect through the localhost port and has all the rights, and there's no check, no authentication, no authorization. So he really flies under the radar. So that was pretty big security problem here. But again, it should be mitigated by now. But just to be sure, check if it's still around. Good. Now let's talk about containers. So we have seen some scanning best practices last week with kubesec and with Polaris and some others. And today, let's talk about image scanning. Okay. So what we're using here is Claire. Claire is an open source project that does static analysis of the vulnerabilities that you might have in your containers. So basically what it does, it looks at the container, and what you can do is from a container, you can see what has been added and basically what is in there. So the version of SSH libraries and whatever. Okay. So what it does, it scans them and checks if there are some libraries, some elements within this image that might have some vulnerabilities. So for example, here you see an example here. And it says here in lib WMF, there is a known vulnerability with CVE 2009 and so on and so forth. Okay. And you get the link to the CVE, whatever. So that's a pretty cool thing. And that's, by the way, Claire is the scanner that OpenShift, Red Hat OpenShift uses as well in the registry, in the Quay registry, okay, in the internal private registry. So Claire is today more or less the standard for image scanning. And one thing to point out is here when you see analyzing 14 layers. What are those layers? Do you remember back 3 weeks when we talked about Docker? When you create an image, you have your Docker file with all the different steps in the Docker file that adds stuff to the Docker file. adds libraries, installs libraries, adds application files, whatever. And here, analyzing 14 layers, that just means that the Docker file had 14 different layers, so 14 different instructions in the Docker files. So what it does basically is that it gets from the container the Docker file back. So you can extract more or less from an existing container the Docker file with which it was built, okay? Obviously, you won't see more specific stuff. So if you copied into the Docker, some files into the Docker container, for example, you won't see all the details, the nitty-gritties about that. But you get the steps that have been used to create this Docker file, and that's what Claire is analyzing. And it's really, really powerful. Now, we will be doing a lab on this one. It's the last lab in the lab section. One thing, perhaps, and I will say that again afterwards, start with this lab, because when you initialize Claire, and that's what we will have to do, it takes a long time to ingest all the rules. So when you start it up, it downloads the container. So basically, Claire is a Kubernetes deployment. So we just deploy Claire into our Minikube. And once it's starting up, it starts pulling in all the different vulnerabilities nodes. So that can take up to 30, sometimes 40 minutes. So I'd suggest we start with that, deploy Claire, and I show you until where you have to go, and then we just let it run, and then you can start the labs normally from the beginning. Like that, we're sure that when you get to this lab part, it should be initialized. Okay. Good. So some more things. So namespaces, use namespaces liberally. So we already had that last week, but I'm coming back to it because now you better understand the Rpac part here. So on namespaces, you can define your network policies to do network isolation between workloads. So you can completely protect a namespace from outside traffic, for example. Okay, your I don't know, in your production system, if you have a backend server, API server with a database, you can completely isolate that as much as possible per namespace. And you can define this RBAC, those role-based access controls, through namespaces. So if you have namespaces like, for example, dev app 1, dev app 2, then you have test app 1, test app 2, then you have prod app 1, app 2, you can give different access, different permissions to different service accounts, different users, different groups, depending on the workspace. So for dev app 1, for example, you can give you can give access to the developers that are developing application 1, but not for the ones that are developing application 2. Like that, they cannot do any stupid stuff and delete and modify stuff in your namespace. So you can vastly reduce the blast radius if some developer, some tester, or some ops guy, whatever, does something stupid. You can massively reduce the blast radius. Sorry. So it's a good idea to use namespaces. Use a lot of them, not too many, but try to use namespaces to really regroup functional and based on environment and based on environment. So as I said, for example, dev app 1 would be a good idea. You might even have dev app 1 front end, dev app 1 backend if it's really big applications, if you want to segregate them some more. But usually at least one namespace per application and per environment. So dev test, pre-prod, prod, and so on and so forth. Okay, and I won't go into the discussion how many clusters we need, should we segregate with clusters. I think we already had that. If you're interested in that, if you haven't participated last week and the week before, have a look at the recordings. We discussed that pretty extensively. Another thing is resource quota. So you can define resource quota per namespace. So you can say, for example, my dev app 1 namespace, they have so many CPUs, so thousands of CPUs. So those here would have half a CPU and 1 gig of memory. So you can limit memory, you can limit CPU, and you can also limit the number of pods that they can deploy. So you can say, for example, max pods is 20. So you cannot deploy more than 20 pods into your dev namespace, and you cannot go over a certain limit. Like that, you can avoid, again, this starvation of clusters. So on one side, from a security perspective, so if someone gets access to one namespace, because you did your Rpac definition correctly, also he has access just to this namespace. If you don't do resource quotas, this guy can go in and just start creating pods and whatever that consume a lot of memory and or CPUs, which eventually will starve your cluster, and then some more important workloads will get killed. Okay, so it's pretty simple. So you can do network policies, you can do resource quotas, and you can do Rpac by namespace, which is really, really good idea. And the second point that I wanted to say is, I mean, I've been, and I said that already once or twice, I've been a developer for almost all my life. I'm still developing stuff today. I know how we are. If you don't set limits, we always get the biggest one. So if you have 3 cluster sizes, small, medium, tall, we get the tall. And if there's an XL, we get the XL, just to be sure that we have enough resources, okay? So devs, again, and that's pretty much autocritical, we have a tendency to always shoot for the biggest or the second biggest environment that we can get, just to make sure that we don't have problems later. And that's not what we want. We want the big environments being reserved for production or pre-production, and for development and test. Usually we need small ones. So like that, we can limit that. We can make sure that we don't starve our cluster to death, and that we stay optimized in our resource usage. Okay, the scanning, we already had that, obviously best practice. Now the last one is the famous Kubernetes dashboard. And you've seen that it gets started automatically in the VM. To play with it a little bit. Yes, I'm making a break in a second. I just wanted to go to the end. I see Yuri popping up. The Kubernetes dashboard, if you don't do it right, it's not secured. Typically on your Minikube, the Kubernetes dashboard is not secured. So everybody who has an HTTP connection to this dashboard has access to this dashboard, and this dashboard has. So someone can go in and start modifying Kubernetes objects, any. So we completely circumvent authorization authentication. So best practice is use authenticated access, Rpac, and that the service account, because this dashboard runs with a service account, and that's exactly what those service accounts are there. You can run deployments, pods, and whatever under a certain service account, and you give limited access to this service account under which the dashboard, for example, runs. And please don't expose it to the internet. I mean, it's tempting, especially today when everybody's working from home and you have to rapidly check something in your firm's cluster. If you install Kubernetes dashboard in your prod cluster and you don't secure it, everybody has access to your production. Okay, so please keep that in mind. I won't go into detail. You do that, just Google it. It's there. There's a lot of information out there, very good information on how to do that. So let me go to the security checklist. But before going to the security checklist, just to situate it again, what we've seen last week, that's typical DevOps process, GitOps/DevOps process for Kubernetes. So with the application source repository, with the Kubernetes manifest repository, we would have here ideally a repository for the infrastructure as service, infrastructure as code. Sorry, and what we've seen is that we're missing the whole security part. So we've seen unit testing, SonarQube, and whatever exists here. It's not our topics here. For before committing our manifests into the Git repository, check with kubesec, Conftest, Polaris, and so on, what we've seen last week. And then we have the image scanning here with Claire. So now we've seen Claire. So it's a good idea that when I build the image before pushing it into the registry, I do a scanning. I scan my image before how do you say, making it available to the population. Okay, so that would be clear. That's what we've seen today. And again, before deploying, when you go into the CD part, deployment part, again, recheck the Kubernetes manifest. You never know who might have been checked in something that's not conforming to the policy. So we do that just to make sure. And then obviously smoke test, queue control, curl, and so on and so forth, integration tests, non-functional tests, and so on and so forth. And then the test of the cluster itself with KubeHunter or Falco or whatever. So Claire, that's where it fits in, the scanning. So please think about doing this image scanning before having it in the official registry, okay? And again, what we've seen last week is here with the validating admission webhook. I mean, image scanning, as I said, might be a little overkill, might slow down things, but you can use other solutions like, as I said, Notary or something, just to make sure that your images are signed, that they have been signed off, and that you're allowed to deploy them. Like that, you can already filter a lot of stuff, so that your developers don't, or your ops guys don't deploy some images from Docker Hub that haven't been scanned, that have not been vetted by security. Okay, and then, well, for the cluster itself, we've seen network policies last week, Rpac to secure the API, TLS encryption, we've seen that, OIDC for authorization, the whole SA Linux and container security stuff for the workloads, the containers that are running on there. Good. Now, the self-check, that's what you've seen last week. So can you be sure that you know where your images are coming from? Okay, so it generally is a bad idea to pull images or to do a deployment in production, let me put it that way, with images that are coming directly from from Docker Hub, for example. So that's not a good thing. Okay, try to pull them, so get them out of Docker Hub, scan them, make sure that they conform to your security standards, and then push them to your private local registry, and then pull them from your local registry. Like that, you're sure that you have certain versions of your containers, that they have been vetted, and that they conform to the security standards. Then the second one, what container services are exposed? Obviously, as we've seen last week, if you start exposing the MySQL database or the Postgres database to the outside world as well, you're compromising your security, because they don't have to be exposed, except if you have very specific use cases. But if you have, for example, a WordPress application that's running in one pod and the MySQL database that runs in another pod, WordPress can access this MySQL database without it having to be exposed through services to the outside. Another thing, and I didn't go into detail last week, 2 weeks ago, and not last week, and I've completely forgot about that. When you're using services, of type node port, you remember this one? That exposes your pod to the outside world, outside of the cluster, with a port number in the 30,000 range, dynamically allocated. But that means that those are directly accessible from outside the cluster through the IP address of the cluster. And if the cluster is accessible from the outside, this pod will be accessible from the outside as well. So be very careful, especially in production and pre-production, to not use node port services to expose your stuff. That's absolutely fine for development. That shouldn't be a problem, unless your cluster is exposed to the outside world as well, and you have mission critical data already in development, which usually shouldn't be the case. So pay attention to the node port type, because it doesn't go through all the hoops that you have normally when using ingresses and TLS termination and what we have seen last week. Okay. Then, do I know which processes are running in any container in any cluster? So make sure that you know what is running in your containers that you're deploying. That's pretty important. Even for containers that you get, for example, from Docker Hub or from Quay or whatever, to make sure through scanning and understanding what is running in there. I have a MySQL container that I've pulled. Am I sure that's only MySQL running, or has anyone packed an SSH daemon in there, for example, which would make it accessible if ever it's exposed to the outside world through SSH? And if ever I have a security vulnerability in this SSH version or whatever, it might be accessible again from the outside, or it can be compromised. Okay, then what network communication pathways are active? That's a pretty easy one. So just make sure to know what is open, what pathways are active. That goes together with the services that are exposed. Then obviously the responsibility for a certain running application. So to know which team in the organization owns a certain application that's running in your clusters. That should be a no-brainer, but it is not always. I've seen customers where they don't know for some parts of applications who's responsible for that. And if we say running application, that may just be a specific container that's running. Okay, so mustn't be a complete application. It can be just a fraction of an application. Make sure who has the responsibility for a certain application, and the responsibility as well to have the whole thing scanned, again, to the point to check which services are exposed, and so on and so forth. So that would be, if you want, the responsibility. And let me just go back rapidly here, to the people who are doing the application operations. Remember last week we talked about application developers. Then on the right side we have the infrastructure operators, and here in the middle we have some sort of new role, which is application operators, which overlaps a little bit with SREs, okay, site reliability engineers, who must make sure that everything's automated and checked and it's running stable and securely. So that's that. Then we have obviously for certain type of customers like finance or public institutions, we have regulations, or pharma, for example, as well, like HIPAA or PCI and so on and so forth, to make sure that the clusters, the nodes, and so on adhere to specific regulations. Again, if you go with prepackaged solutions like OpenShift, for example, they have certain approvals for certain compliances with PCI and whatever. Okay, so if you're building it yourself, make sure that you respect and you adhere strictly to those regulations. Privileged containers, if ever you have to use privileged containers. So you shouldn't, but there might be some cases where you have to, if you have to access some stuff on the host system, like logs, for example, stuff like that. Make sure you know exactly where are those running, who is running them, who's responsible for that. Because if you don't, it will get complicated, because you have some pretty open and potentially dangerous things running in your cluster. So make sure that you know the responsibilities or that you know who has the responsibility for those. That's pretty important. Now, what we've seen today, make sure that you know how often your images are scanned. So typically Claire would be something that you run regularly over your containers. Okay. If there are vulnerabilities, what's their severity? What is the impact of the severity? Have a plan, have a governance model to say, okay, for a certain number, or perhaps we don't allow severity 1 vulnerabilities, in which case we cannot deploy. Then you can say, okay, we can have perhaps 1 severity 2 and perhaps 3 severity 3. Define your thresholds. Be sure that you know with what known vulnerabilities, with what detected vulnerabilities, how do you want to react to that? Do you block the deployment? Does it go back to the application operator, and so on and so forth? So have a governance model for that. Are there any containers in production that are impacted by known vulnerabilities? That's pretty important, okay? Because when you deploy an application into production, it might be that 3 weeks afterwards, a new vulnerability is detected. It's not that if you have scanned something and you deploy that into production today, that tomorrow it won't be vulnerable because a new vulnerability has been detected. So make sure that if you detect vulnerabilities, that you know if there is any containers or any deployments in production that are impacted by that. Okay, and then obviously if you have to remediate it, prioritize the ones obviously that are running in production already, that are running in systems that are exposed to the internet, to the outside, and so on and so forth. So all of that, point 9 to 11, goes really in the direction of please have a governance model for security and for vulnerabilities, because you will have vulnerabilities in your containers, inevitably. So you cannot go around that. Good. Questions? I don't have any questions in the Slack channel. So I don't know if everybody's asleep or if it was clear. Okay, Muhammad is typing. Do you have questions, guys? Didn't sleep. Thank you, Muhammad. Very good. Happy to hear. Oh, it's not clear, but I'm trying to understand. Okay. So perhaps we'll take that offline afterwards during the lab, so we can have the discussion afterwards, if that's okay with you. So several people are typing, so I'm just waiting for the questions or whatever popping up. Let's give it 30 seconds. Yes, need to do more offline reading to come up with questions. Yeah, it's pretty complicated topic, especially with this Rpac stuff. But what I suggest is that we're going into the labs anyway now, that you do the lab exercises until 5, and that should leave you largely time enough to do that. And if you have questions during the lab exercises, we're here to help. And if you have questions afterwards, try to dial in next Tuesday, 5:15, and then we can discuss that, and we can unmute that, and we can discuss that directly without having to go through Slack. Okay, then Ramesh has a question. Are these things more inclined towards DevSecOps? Yes, I mean, you can call it GitOps now or DevSecOps. It's a bit of all of that. The idea here really is to, I mean, DevSecOps is all about delivering features faster to the end customer. So you have an idea, the business has an idea, you want to shorten the time from the time this idea pops up to the moment that it generates value at with the end customers, that you can shorten this time. So that means obviously a lot of automation, a lot of agile processes and whatever. And that's basically what we're doing with DevOps. So DevOps is just bringing all those guys, and we say just saying Dev and Ops, but there's testers in there, there's the security guys in there. There's a lot of different roles that are in there, and what we should make clear and what you should make sure if you want to have a good and a fast DevOps process is that all those people work together from the get-go. So all of those roles should be in the Scrum meetings, in the stand-up meetings together, and should specify stuff together. So when you plan for a new features, when you start specifying it with the developers, the testers are already there, and they can start writing tests before the developers even start to write their code. So like that, you're sure that you can run those tests continuously and refine them over time while the developers write their code. The site reliability engineers can start developing the missing automation for the whole thing, and so on and so forth. And ops guys can start thinking about what's the infrastructure that's needed and start to set up the infrastructure that's needed for that. So the idea here really is to talk about the whole enchilada, all those different roles, starting to get together, understanding each other, understanding the the different roles and the different concerns that they have. But and you can see now I'm getting down the rabbit hole, because you started talking about my second favorite topic, which is DevOps, that I've been doing for like forever now. So the idea really is to help, for example, a developer understand what the challenges of operations are, what is a load balancer, what is network isolation, stuff like that, so that the developer can predict what the problems might be when you put that into production and you roll it out. On the other hand, operations guys must start to understand, or have to help them understand, what agile is, how does it work, how do you develop in an agile way, and so on and so forth. I mean, for most ops guys, that's black magic. What's this black magic? Stand-up meetings and stuff like that. So help everybody understand, and then comes in the security, which often is an afterthought, and that's an absolute problem. We have to start building in security in this automated process, and we need automated security. It starts with just with unit testing, which is probably more for coverage, for functional testing, but still. And then we can start with statics and security analysis, for example, on the code that's being produced. And you can do which could be called white box scanning. Then you can do black box scanning when you deploy it into a smoke test environment, for example, just to check, like having an automated hacker attacking the application that has been deployed, to try to find pretty easily exploitable vulnerabilities and stuff like that. So that's why I'm saying, so DevSecOps, DevOps, or GitOps, it goes all in the same direction. But security, especially in a containerized, or in a microservice environment, or even worse, in a hybrid environment, where you still have stuff running on VMs and you have some stuff running on microservices, everybody's talking to each other, and so on and so on, that you have this governance model from well, the governance definition down to the tooling and the processes in between, that you have that in place, that you know what you're doing. Like that, you're pretty sure that when you create new code, new features, they can go through this pipeline and you get all the low-hanging fruit. So you can get probably 80% of all the functional problems, performance, non-functional problems, and security problems you can get out of the way like that. Okay, so that's the idea. And then GitOps, what I said, it's just basically it's like DevOps, but it just means that everything is being committed to Git. So you have your application source in Git, you have your Kubernetes manifests in Git for the application operator, and you have your infrastructure as a code in a Git. So everything is retraceable, everything is clearly auditable, so you know exactly who did what when, and that helps a lot with what we call root cause analysis. So if you roll out a new version of your application or of a new feature, and it goes south, or it doesn't work, or you have a security problem or whatever, you can go back and do root cause analysis and check what has been changed in the code exactly that has produced this problem that we have right now. And you can go back to the person who made the change. So you can go back, not to bash him, but to say, okay, we have a problem. That's the problem. You made the change. Please mitigate. You can really go back to the source and understand what has happened exactly. And that's where this GitOps comes from. Okay, then Kevin. Okay. Not clear, but trying to understand. Possible to have another session in security. That's not planned. Yeah. Oh yeah, Pascal. Yeah, the developer unconference. There's some very interesting stuff in there that might be might enlighten you. The presentation slides are not looking same like those on GitHub. No, you're probably checking out not the slides, but the labs. I haven't uploaded the slides yet, if I'm not mistaken. So they will come after the presentation. Can we get this PPT? Yes, you will get that. As I said, I will upload it on the public training public repository. Okay, Pascal already replied. And to DevOps Cloud, and I understand you. Yes, thank you, Ramesh. Yeah, I mean, we could talk until 8 o'clock this evening for another 4 or 5 hours about DevOps. it's a very vast topic, but as I always tell my customers when we talk and when we get to know each other a little bit, DevOps in the end stands on the shoulder of dynamic infrastructure. And dynamic infrastructure is infrastructure as a service, but it's also Kubernetes or containers as a service. So it can be IaaS, PaaS, CaaS, whatever. So if you want to do efficient DevOps transformation or continuous delivery, whatever you might call it, there's 100 different names under the sun for this. Just if you want to optimize your delivery speed and cost, then you need underneath, you need some transformation from the infrastructure perspective. And most of our customers today, they already have and have had for years now VMware or OpenStack and stuff like that to be able to spin up VMs, for example, rapidly. But again, I had a discussion with a customer a few years ago when we were discussing, and I asked him, I said, how long does it take you to get a VM if you want to develop something new? I said, well, okay, I'm writing an email, then it takes like 2 to 3 hours. I get an email back and my VM is running. I said, okay, cool. And now can you use it? Can you start developing? Oh no, afterwards I have to wait for 3 weeks until this VM has been added to the subnet and I can access it through a public. So it wasn't 3 hours to get the VM. It was effectively, in the end, it was 3 weeks until it was really usable. So that was a big problem. Then we had the infrastructure as a code and the whole Terraforms and Ansible and Chefs and Puppets and whatever. That helped a lot automate that. But we were still on the very highly non-granular level of complete VMs that we've seen 3 weeks ago. And then came the whole containerization, microservices, transformation, and so on and so forth. And that helped a lot because here you have a platform where you can give access to certain groups, certain people, to certain namespaces, certain quotas, and so on, with certain network segregations. And they can just go on and start deploying their stuff. And they don't have to worry about starting VMs and whatever. But they can work very well hand in hand, and that's the good thing about this hybrid multi-cloud where we're going to. You can start taking your VMs. You still have a lot of VMs, and you start slowly transforming them into containers and into microservices afterwards. Because what happens very often, and that's I want to close on with this one, and I think I talked about that in the first installment. And that was a customer discussion I had as well some years back when we started talking about microservice transformation, and I was like keen on lecturing him on how to do this microservice transformation, and he told me, no, we do it the other way around. They just get, for example, a web application archive, a WAR file, for example, a Java application, and they containerize that. It can be a huge hunking file, like a 500 megabyte file or 1 gigabyte file can be really big. They put it in a container and they run it in a container. And I've been saying, and sorry for those who already heard that in the first installment, but I think it's pretty important. So I told him, but why would you do that? Why don't you do microservice transformation? He said, well, it's complicated, it's long, and it costs a lot of money, so we don't do that yet. But why I'm doing that? For 2 reasons. The first one is immutability, what we've seen in the first installment with Docker containers. You create your Docker container, the image, to be more precise, you close the doors, and that's it. You don't modify that anymore. And then you're sure if what you have developed in dev, what you have tested in test, is this exactly same thing that will go to prod. So that eliminates this works on my machine syndrome. And that's very, again, it's very developer-like. I mean, I don't know how many times I said that in my life, but a lot. Yeah, but it works on my machine. I don't understand. And through this encapsulation and through making sure that you have this immutability within the containers and through the different environments, you can eliminate that. So you're pretty sure that what you deploy into prod corresponds exactly what you have developed in dev. Okay, that was the first thing. And then secondly, he told me, yes, we started some microservice transformation. So the cool thing with that, what we're doing here, is that we can use exactly the same pipeline, the development and deployment pipeline. Because if I'm packaging that in containers, if it is like a macro service or monolithic container, or already a microservice transform container, it doesn't matter. The pipeline is more or less the same. So I can standardize on how my developers, my testers, my operations guys work through this platform, and then I can start when that has been done and the automation has been put in place. I can start transforming the whole thing, and start ripping out chunks and creating my microservices. But I don't have to modify the way of working afterwards between different groups or different teams. And that was pretty interesting as an insight. Okay, very good. Other questions? Nothing. Ramesh is typing. I can probably wait. Thanks, such a good insight. Yeah, I thought so as well. I mean, it's pretty stupid, and you know, when you learn new stuff, and Ramesh probably understands that very well. When you're new to Kubernetes or new to microservice and everything, you learn the theory, the basics. When you get out of university, you're full of good ideas. I mean, I remember when I came out of university, database normalization was a thing. So you had the first normal form and whatever, I don't remember exactly. So you had to split everything up and to have a superbly optimized and beautiful model. And then I went to work with my first employer, and we had worked on my first project. We had a huge chunking database, and we did several weeks of normalizing this database. It was really a lot of work, but we did a pretty good job with all the controls and the checks that you learned at university, whatever. And then when we started testing the whole thing, performance was absolute crap. It just didn't fly because we completely normalized the whole thing, and it wasn't performant on the database engine that we were using. So we had to go back and denormalize and have our big, huge tables again with all the data in it, and then it did work. But that was a pretty good lesson, like 15 years back or something or more, 20 years back now, 25 years back, that it's good to understand the theory. And that's exactly what I've been doing. I'm giving you theory. And that's why I try to talk a little bit about all these little nitty-gritty practical things. It helps you understand that theory is good, but practice makes the master. So really practice as much as you can, and that's where you get really proficient and to be of good help to your customers or to your peers. Okay, what do you say? Should we create a Slack robot for Kubernetes named Nick, where you can put your knowledge? Yes, well, I'd have to put my brain in a container and then put it on Docker Hub. That would be cool. But no, more seriously. So if you have questions, so if you have additional questions after today or after this series, you could either dial in, as I said, on the Tuesday evening sessions from at the 5:15. There we can really talk with voice with one to each other, not just through Slack. That would be one possibility. Otherwise, just drop me a mail or ping me on Twitter or on LinkedIn or anything. And I'd be glad to have a discussion over the phone or WebEx or whatever with you. If you have questions, if you want to go a little bit into experience exchange or whatever. Okay? Very good. Okay, so it's 56. Let's break here.